All right, I will start over the lesson. Now I give you the file, right? I've given you a file. Now to start with, I would like to give you 15 minutes. Okay, 15 minutes to take a quick look on that and try to mark down some important items before we come to the discussion of those. Okay, I changed a little bit this time with the format now. Do you find it? So your file.
I do not see the file.
I just send it again. Okay, so make sure all of you have received it. Just put it in the chat box. Or receive it. All right. Are you ready? So go to Redox. Now I will give you about 15 minutes to do your work first of all, because you may need to read the questions very carefully. Okay. In your chat box. Okay. Except before those students, right, you have now anyone who can send it to the chat box. Okay. Now, while you proceed to the work, I would like to remind, right, those students who haven't come to me for the debriefing of your QA. You have to come to me today. Okay, you better make it this afternoon. Okay, most probably then maybe after 2:30, because I need to have a meeting with colleagues. So you better make it today to come to me. I try to come to me while your memory is so fresh about what you have done in your qualitative analysis. It's not just merely submitting a work up, because, instead of you need to have a very clear flows of thoughts about how you come up with the answer. Okay, you know what to do now? Now this time I change a little bit. Okay, it's for those people just like Jen, when it's time to wake up and you focus on your work. You have to focus on your work. It's time to wake up, brush your teeth, don't lie on the bed. Don't tell me that you are still on the bed. Just sit properly and take a look on the work and do it now. Okay, all right. So 15 minutes. Shall we start now? For those who are having breakfast, could you please make it as soon as possible? I know that you are eating something.
Breakfast would be a luxury for me.
Yeah. Just doing it right now.
I already finished. I mean the breakfast, not the exercise.
I don't know. It can be. Can it be the one? Okay. All of you, please come back. I do think it is necessary to wake all of you up using this type of method. All right, so it's easy, right?
OK 啦，OK 啦。
OK 啦。好 ，so you just check。有十幾分，有十幾條，每人一次啊！又嚟啦，每人一次啊！我哋由陳龍王開始啊！陳龍王。Number 1, describe the current flow in the following circuit. This one. So you may turn on the mic or you can type to speed up the whole thing. Open the so strange. Anyway, electron flow from zinc to copper, yes. But according to the questions, what is it asking for? Now there is a electron flow. So yes, that's right. So if you talk about the electron flow, direction of electron flow, it is from zinc to copper. What is it called in this part? In the external circuit. So this is the point number 1. I would like to remind all of you while you express the answer. And while you say the current flow, it is the opposite direction. It's from copper to zinc in the external circuit. Okay, thank you. Chen Zihin, what is the subbridge? What are the functions of subbridge? How to make a subbridge? Chen Zihin, where are you? Chen Zihin, are you here? Yep, tell me. Just answer any one questions that you know. So something about bookwork or about subbridge. 我知嘛 subbridge. There are two functions of subbridge. Still remember? Yep, complete the circuit by allowing ionic movement between two half cells. What is the second functions to prevent what? Yep. Prevent the cells, stop the cell reaction. Yes, that's right. So how to make a soft bridge? How to make a soft bridge? Right? How to make a soft bridge? Right? Are you here? How to make a soft bridge? Wang Junhei, you should prepare answering the next question. Okay, oxidation number. With an electrolyte. Wow, your answer is so safe that you score no marks. Yeah, potassium nitrate solution, possible. Okay, possible. How about yep, solution? Yeah, aqueous potassium nitrate solution, saturated potassium nitrate solution, also possible. And in this case, there will be no more or conflict about that, except if you have, for example, this chemical, for example, we've got lead and then lead salt. So if you, I can see some questions like this, right? They ask for having sodium carbonate solution or potassium sulfate solution. Is it possible? The answer is no. Okay, why not? Now, after doing the QA, right? Yeah, after doing the QA, you know, there will be some PPT. So for the criteria of the solution suitable to use as a soft bridge, you need to aware of two things. One, please be aware of any precipitation reaction. Second is to be aware of the redox. So never put any OA or RA here. A strong OA or a strong RA in the soft bridge. No, it is not possible. Okay. So on today, take a look on the next questions. Oxidation number of oxygen and nitrogen. That too.
Okay. The first statement, the oxidation number of O in all is compounds is -2 is not correct. There is an exceptional case, which is hypochlorate, whose hypochlorate.
Hypochlorate. So what is that?
Sorry. ClO minus.
Just say hydrogen peroxide. Then it would be an exception case.
Now, for the hypochlorite, take a look on the oxidation number of O. O here. O is still -2. Okay, while this one is +1. So we have got a systematic name. We talk about this hypochlorite ion being named as chlorate 1 ion. So the 1 here refers to the chlorine oxidation number. So for oxygen in all of this compound is -2, you need to think of some exception case. So exception. So except, first of all, H2O2. Why? Because the oxygen here, right? So we have got the oxidation number -1. OF2, good one. OF2, what is the oxidation number of O?
+2.
Yeah, this one is +2. So remember that 2, they are very, very special case. So you need to pay attention to this. Okay, is it clear? How about the next question?
The oxidation number of nitrogen in ammonium nitrate is not only it's not +1. It should be -3. It should be -3 for ammonium ion and +5 for nitrate ion.
Yeah, correct. So you should be highly aware of the sentence, right? Oxidation number nitrogen in ammonium nitrate. So this case is very special because both the cation and anion will have nitrogen containing. Second, the oxidation number of nitrogen, and in these two ions, they are much different. And this is to remind most of you, why you are going to relate to rate it to something like a change in oxidation number to relate to oxidation reduction, right? Sometimes a very clear wordings is needed. So you have to tell me the nitrogen, oxidation number of nitrogen in what species, right? In this case, I just put the whole case into one compound, ammonium nitrate, and you may find that, yeah, as a bit confusing. I'll remember to put it as detailed as possible. Next, 燒盡氣。燒盡氣。Instead of just telling me here, could you please recall your memory about this? Oxidation of and reduction in terms of gain or loss of oxygen, hydrogen, electrons in terms of changes in oxidation number. Oxidation means gain in oxygen, loss in electrons, and hydrogen atom and decrease in oxidation number. Do you know why I asked that type of question? And for the rest of you, do you know why I asked this type of question? Okay, anyone who can correct it for him. Sorry, it's wrong. Magura. Yeah, increase in oxidation number. So if you want to talk about oxidation, you talk about the gaining of oxygen or losing in hydrogen, or you want to talk about losing electrons and increase in oxidation number. And reduction, losing of oxygen, gaining of hydrogen, gaining of electron, and now decrease in oxidation number. Now, definition of oxidizing agent and reducing agent. Are you here, Magula? So if you say so, there will be no problem. But if you take a look on this question, okay, if you take a look on this question, consider the following reactions. You are going to define oxidizing agent and reducing agent. How will you answer? And give me a reason. You're going to identify this time. Can you tell? Oh yeah. Yeah. You raise your hand, but you have to tell me instead of raise your hand. Okay, you may turn on the mic as well if you want to, or you type it in the chat box. Let me know. Chlorine is oxidizing agent. Why?
佢 oxidation number decrease 咗。
Oxidation number decrease how？ 我睇下你攞唔攞分先呢度。Oxidation number decrease。
由CL2 即係 chlorine 嗰個唔係由 chlorine 即係嗰個係0啊嘛，跟住變咗 NaCl 嗰度負1。
Chlorine in now remember you need to give a very clear verse. Chlorine in Cl2. Okay, it is from 0 turn to that. It is in what? NaCl. It is what?
負1係咪？
Minus 1. So it undergo reduction. So what is the reducing agent?
NaOH
NaOH. Why?
唔知喎，睇緊。
Why?
好似唔係喎，好似唔係。個 CL2 自己咩，跟住變咗 NaOCl 嗰度。
So what is the reducing agent?
CL2
Why?
佢由 oxidation 佢由嗰個 oxidation number 喺嗰個chlorine 嗰度係0，跟住變咗 NaOCl 嗰度係
Which oxidation number are you talking about?
正1 NaOCl。
NaOCl, we have got 3 elements. Which element are you talking about?
咩 chlorine
Yes, so you are going to tell me oxidation of chlorine, okay? It's we have experienced an increase in oxidation number. So what is that very special type of reaction in Redox? A very special name. You know what's that? So in which having the chlorine Cl2 being an oxidizing agent and reducing agent. And you may find the reaction undergoing redox, self-redox simultaneously. So what we call that? 我要諗，知唔知叫咩名？呢個死啊！真係
個咩 dispor 唔知咩 disproportionation。
Okay, you read it again. Disproportionation
reaction。
Disproportionation reaction. Proportionation reaction. Disproportionation. Okay, so it is a type of self-redox. So self-redox is a very common term. It's a common name. But if you are asked to write in DSE, please write down disproportionation reaction instead. Okay? 真係好彩問一問啫。你有冇發覺幾條問題都係啊？我好彩我問一問啫。嗱 ，even 呢條啊，咩 definition of redox 啊，好彩問一問啫。Ben 小學，好，潘樂志 ，take a look on the second one。
係邊度啊 ？OK
OK 喎嚟咯，打錯字啫，唔使咁嘅。咁希望你 DSE 唔好寫錯字咯，咁就唔使咁咯。啱唔啱先？張永熙，我都希望你唔好寫錯字。 有陣時係啊，好大意噶嘛。大意都人之常情嘅，啱嘅。係嚟啦。
錯啦，個調轉咗啦個 positive negative 嗰度，應該係有 coffee deposit 上去咗一個。
即係呢個係 negative 啊，呢個 positive 係咪啊？係錯咗啊？係咪啊？
係
啱啊。OK 啱啊。OK 又好彩問一問啫，講錯嘢啫，唔使咁嘅。好，算唔算？我俾次機會你講啱啦，算唔算？呢一條應該點啊？DSE is an anode, A is an anode, B is a cathode. OK, A is an anode, B is a cathode. 所以咧，因為呢啲好得意嘅，呢度提咗你㗎啦。呢一度 positive terminal anode 嚟㗎。嗱，好多人咧呢度咧係會成日搞錯嘅。OK， now this one is not correct. Okay, so cathode is correct. So, how to first of all, these naming of cathode, anode, positive, negative electrode is quite different from that in chemical cell. Okay, so chemical cell, electrolytic cell is different. So if you want to identify the nature of the electrode, okay? So if you want, anyway, you have got positive pole and negative pole for the electrode. So how would you say so? So for negative electrode, it is a place where there is a losing of electrons will occur. So we will call it anode. Okay, while this one is cathode. But if you want to talk about electrolytic cell, the way to define it is a little bit different. So for positive electrode, they will attract anions, so we call that anode. Okay. While you talk about negative electrode, the negative electrode is cathode, while cathode attracts cation. It's easily confused. It's easily confused. So this is what I would like to remind all of you. Marcus. Next question.
Let me check. No, doesn't work like that. Oh goodness.
Was
no, I need to remember. I remember what it is now. Give me a second.
Yeah.
No, for dilute nitric acid, the calcium actually does get oxidized into like calcium nitrate, right? But it isn't hydrogen gas that's being produced.
Is that? What's that?
It's actually no, it's NO.
點啊？好無聊啊！唔該你。Okay. So it's NO, right? No gas? No gas?
No, not no gas.
It's no gas, right? So nitrogen monoxide and water. So balance equation, please.
All right, 3 calcium plus 8 dilute nitric acid equals to, it goes to like 3 calcium nitrate plus 2 molecules of nitrogen monoxide plus 4 molecules of water.
OK，thank you。38324記住啦。係啊，好多同學成日搞錯咗38324啊，1412嗰啲。呢個搞掂佢啦。咁乜唔係出 hydrogen gas 嘅咩？即係 calcium 係咁啊！即係點解會出現咗呢條問題咧？好多人咧會撈亂咗嘅，撈亂咗咩咧？嗱如果我呢條題目有 copper 咧，冇懸念啊，好多人就會識噏38324有 nitrate， 但唔知點解咧去到 calcium 嗰陣時咧會諗咗 hydrogen gas 嘅。點解咧？因為有啲人 confuse 咗呢個所謂嘅 dilute nitric acid 啦。第一啦。佢以為係一個 typical acid。Okay, so which gives you a confusion. Okay, it gives you a confusion. So to form hydrogen gas as usual, just like magnesium, put it into any dilute acid. 咁呢個咧 which wrong， 呢個唔啱嘅，得唔得？嗱 copper 你又諗得到喎，但係 calcium 啊 magnesium 咧好 fit 嘅呢個。勁搞鬼嘅呢條題目，咁每隔幾年 DSE 咧都會問，好麻煩嘅呢個。OK， 跟住好張家榮。張家榮 to acidify potassium permanganate， 打佢啦，張家榮。點啊？呢個係啦 ，to acidified potassium permanganate can only use H2SO4 to acidify. So which one? AMNO4 or dichromate, potassium dichromate? Both cases. Okay, what H2SO4 of what concentration? Dilute or con? Dilute. Okay, dilute. So this is not correct. It's not correct. Okay, all those answers not just correct. If you are going to ask for non-oxidizing acid, I use dilute H2SO4. 好，咁順便問埋張家榮啦。How about silver nitrate solution? Last Thursday, we often acidified it before we use. So what acid is needed? Dilute nitric acid. But dilute nitric acid is an oxidizing agent. Why do we need to use dilute nitric acid in this case? Why? Prevent PPT to form, but why not I use HCl or H2SO4? Prevent PPT to form. Okay, go back to the explanation raised by Zhang Gaowing. Prevent PPT to form. I'm sorry, I cannot give you marks for this. So you know it. So you know for HCl and sulfuric acid, once I add it to silver nitrate, they will form some insoluble substances before I react with the sample to be tested. Okay, one is silver sulfate, one is silver chloride. But go back to the question itself. Dilute nitric acid Why is it used to do so? So according to Zhang Gaoying's answer, you just say that prevent PPT to form. Isn't it you're looking for PPT? Why you say that prevent PPT to form? What does it mean by that? 唔明，唔明，即係呢一句説話我俾唔到分嘅。但係你記住啊，我問你點解要將硝酸銀消化，話用稀嘅硝酸 ，OK O 咩嘅啊 ？get 哦，我有啲嘢唔 get 啊，你幫我澄清下，再問多次啊，你 get 啊嘛？咁啊，點解要酸化硝酸銀溶液？個邏輯唔係因為另外嗰兩隻酸同 sulfur nitrate 有 PPD， 所以用 dilute nitric acid to remove to eliminate。喂，哇！如果真係考試嗰陣時都幾大鑊啊 ！To eliminate CO3 or SO3 to avoid to remove carbonate to prevent interfere of results。唉，大件事啦〜any complete answer for this? Why we use dilute nitric acid to acidify silver nitrate? To prevent something, yes, that's right, to prevent the possibility. All three, please mark it down. To prevent the possibility of forming PPD other than and silver halide, okay, which interferes with the results, with your judgment, okay? So remember, you are going to get rid of some other possibility, right, of formation of other PPT. Okay, so whenever you are you have acidified that, and once there is a PPT form, you can only narrow down the combination, the possibility as silver halide. Can you get the point? So this is somewhat I would like to draw attention to this. Now, the last 1, 2, 3 questions. 好，左邊個未答？前面啊，好似，打大佬啦！前面嗰啲開始難答啊，嗰啲嘢越嚟越長，越嚟越複雜啊！陳浩希，
係就係嗰個red 轉 blue 咯，跟住 blue 轉 red。red
轉 blue 咩 blue 轉 red 啊？咩意思啊？即係話嗰個第一句係咪啊 ？negative terminal 嗰陣時就係紅色轉藍色，係咪咁意思啊？
係啊，
色轉藍色。咁呢邊咧就係藍轉紅色，係咪啊？係咩意思啊？係啊。係咩啊？
唔係，係 green 轉 blue 啊，跟住係 green 轉 red。
哦，你頭先係咁講嘛，我咪照寫咯。
梗唔係啦。
咩梗唔係啫？係嗱，你問下人話我冇屈你啊？你問下其他人，我聽到大家聽到啲咩？你話第一個係 red 轉 blue，第二個 blue 轉 red 啊嘛？咁我咪照寫咯。
red 係原嗰個 red。
係啦，你知唔知？exactly 就係你哋喺written exam 入邊咧，點解成日都好似做唔到 effective communication 嘅一個好好嘅事例？原來佢 原來真係會咁喎，即係會有陣時自己寫或者自己講咧，以為自己講得好清楚，咁但係咧原來你真係表達寫上嚟咧，對方聽到嘅嘢係兩回事嘅，得嘛？或者睇到係兩回事嚟嘅。嗱，咁呢個咧就係你問我喺呢條題目入邊其中一個我都要即係希望攞到 attention 嘅地方。咁 OK， 好，原因。
因為喺個 negative terminal 就會有個 build up of hydroxide ion， 跟住喺個 positive terminal 就會有個 build up of oxidizing ion。
好，點解會有 build up of hydroxide ion at negative terminal？
因為oxidizing ion 就係 continuously consume 啊，跟住 water 就
咁啊 consume
continuous dissociate to form excess 嘅 hydroxide ion。
訓練下自己喺9點幾嗰陣時都寫，即係講到或者寫到比較完整少少嘅意思嘅嘢。Now, hydrogen ions gain electrons to form hydrogen gas. During this process, water will continuously self-ionize, okay, to replace the loss of hydrogen ion. So, with the hydroxide ion being not reacted, they were just left behind and make the solution around negative terminal blue. Now, similar cases that you use a similar logic for positive terminal, and you may think of this hydroxide ion to form oxygen gas, and leaving hydrogen ions left behind near the positive terminal and make the solution acidic. Now, 跟住蔡仲想 when electrolyzing concentrated sodium chloride solution using carbon electrode, pure sodium hydroxide will be formed finally. 蔡仲想 are you here? Yeah, that is one of the cases. Chlorine gas will dissolve back to the electrolyte to form sodium hypochlorite solution, and which makes the NaOH not pure. Yeah, this is one of the reasons. There are so many reasons. Reason 1, chlorine dissolves in water and make the solution impure. And second, while you see the word finally, it's a matter of time of electrolysis. Now go back to DSE syllabus. You have been asked about this type of question. For example, first 5 minutes, what will happen, and then in the later stage. So you may find that the preferential discharge of ions will be much different, especially on anode. So for the first 5 minutes, it is chloride ion to form chlorine. In the later stage, it is what? Hydroxide being preferentially discharged to form oxygen gas. So leaving behind, there may be some trace amount of chloride ion, still chloride ion. They are found inside the concentrated sodium chloride solution originally with that electrolyte. So of course, the solution must be impure. There's not just NaOH, NaCl, NaOCl. We have got so many different sources inside. 明唔明講咩？所以咧呢個咧係 我哋做 long quick 嗰時咧係問過㗎，記住啊！嗱，小心啲，人哋講緊做 electrolysis 嘅時間值。點解會諗時間咧？因為見到即字 finally 咧，我腦入邊要諗啦兩樣嘢啦。一開始 chlorine 就變 chlorine gas 啦，但係放耐咗，隨住 個 sodium chloride solution 嘅濃度下降嗰陣時咧，係開始有啲咩？係開始參雜咗一啲 oxygen gas 嘅 formation 啦，得唔得？明唔明啊？咁你去翻條題目，佢話 sodium hydroxide solution pure 啊嘛，呢個説話其實有問題嘅，因為我仲有其他嘅 source 喺入邊嘅，包括因為chloride 有啲未 oxidize 翻，剩翻喺 solution 入邊嘅 sodium chloride 啦。第二個可能性係咩啊？頭先講咗啦 ，chlorine gas 佢 form 咗之後咧，佢即刻溶翻落去個 solution 度。咁呢啲咧都係一啲唔理想嘅畫面嚟，而令到個 sodium hydroxide purity 咧受影響嘅。今日度明啊？嗬 ，get 到啊？好 ，last 一條啦，呢條我問下邊個未答嘢先咁啊？唐家豪啊。點解啊？ Okay, very good. Molten. You see the molten. Okay. So for molten lead to bromide, we have got only two ions. One is bromide ion, the other one is lead 2 ions. So for those cases here, now just like what you have very often in your essay, you will receive a snake and a 0. Okay. So this is what I would like to draw attention to the word molten. Molten. It's very, very important. Molten. Okay, is that clear? Is it a good sign of waking you up? Now, just a reminder on your coming external mock exam, except before 30th of December, I changed the time, the date to 30th, you know, to give way to biology. Okay, morning, and we have got a ASME mock. Okay, I will start it punctually at 8:30. Okay, do not just tell me that you cannot wake up. 精工still no any new arrangement, just treat it the same. And similarly, is our school final exam, your mock exam, the final exam, internal mock exam. Okay, still happen. Don't worry too much. Okay, I don't think that you will have any cancellation. Which date you will receive the news of the school notice very soon, because we still need to wait for the Secretary for Education to say a few words before we announce anything new. Have you ever heard of anything from the Secretary for Education about any updated arrangement? No. No, just one or two sentences talking about after thorough discussion with the school principal and some other parties. Okay, the updated arrangement will be posted in due course. I heard of something like that, so we need to wait. Okay. Anyway, it's time to take a break. See you guys. Okay, see you guys in the mock punctually. Bye bye.